Well, hi, good morning, and thank you so much for joining me here. It's April, April 7th, 2024. Beautiful sunny day outside. Beautiful dark blue sky, hot sun, fantastic. Tomorrow's the eclipse. The clouds are moving back in. It's going to be cloudy tomorrow. Terrible. So, maybe not. Who knows? Keep hope alive. Well, what's going on with this radio? That's a good question. So someone else has done work on the radio. The radio itself does not work. If I turn it on, it does not tune anything. Something is wrong in it. I don't know what yet. I've tested the tubes. Tubes are okay. Some sound comes out of the speaker. Seems fairly impervious to grabbing the antenna or doing anything with the antenna. Nothing seems to change. So there's something fairly significantly wrong in the radio. Now, I noticed when I first started working on this radio that there was a resistor mounted here and there's another one mounted here, and they're just right across the light bulb socket, which I thought was kind of unusual. But then in studying and it is unusual, and then studying the schematic, I discovered in fact that the lights are actually fed straight from the power line. Well, I'll take that back. They're fed in series with the tube heaters, which is a little bit unusual. I believe it has these resistors paralleling across the light bulbs for a safety reason, should a light bulb fail, so you don't end up with 120 volts sitting right across the light bulb contacts if you're foolish enough to try to change the light while still leaving the power switch on. Are you that foolish? But then things got a lot stranger when I looked in the radio and I could see a diode installed in there. I'm still not sure where the diode is because I haven't done any more since the end of the last video, really. At first I thought, oh, well, they've just installed a diode across the vacuum tube here, and so you can pull the vacuum tube out and just have a diode sitting here. You know, that would probably work. You got a little bit of a problem with the heater through here, because if you pull the tube out, you're pulling out this heater, and then it's open circuit, and the radio's not going to operate. So finding the tube in place with the diode kind of suggests the tube is dead, couldn't get another one, stuck a diode in, why not? You know, time has gone by since when the radio was made, and now these diodes exist, so why not put in a little silicon diode there? That'd be a great idea, except the diode is not installed here, and the vacuum tube, it works fine. As far as I know, the vacuum tube is doing its job in this radio, but I don't know that far yet because funny things have happened right in here. So another really curious thing is that this radio comes with a power cord that is actually a resistor. Now, this is not a terribly common thing. I think it was a poor engineering design back in the day, but a number of radios were made with voltage dropping power cords. So you plug it into 115 volts, but what the radio gets is 15 volts less, 15 volts dropping on the wire. Something like that. I don't know that it's 15, but it would be something like that. Well, this radio doesn't have the original cord. It has a regular cord put in. This is not a resistive cord. In fact, it's quite the opposite. No desire to have any resistance in this cord. So plug it into 115 volts. 115 volts is going to be presented right to the radio. What I think some clever guy did. Why did he install these up here? There's a resistor in the radio, a special high wattage, very high wattage, metal clad wire resistor designed to do this job here. Two 40 ohm resistors. They're in a single unit, a single package, if you like. I'm taking a wild guess at this point that what I'm going to find is the guy figured out that he could replace those two 40 ohm high watt resistors with these. These are not nearly the high wattage that the other ones were, so it's kind of weird. Why did he think this was going to work? These are tiny resistors here. I thought these might be diodes, but I'm pretty sure they're resistors. I mean, maybe I'm mistaken again, but I can't imagine these are diodes. So he's relocated the resistive elements up here. He's freed up the resistor here that's in the radio, the big one, and he's used that big resistor as the voltage drop for the replaced wire, the replaced cable. So in other words, instead of the voltage dropping on the wire here, it's now dropping right across this resistor. Clever guy figured all this out. Or did he? So the diode idea doesn't fit in here at all. Like, what's the diode doing there? The only purpose of a diode, in my view anyway, would be to replace this. So what I'm going to do is I'm going to drink a little coffee, and then I'm going to, on my own, study this situation in this radio until I resolve the actual circuit that's in there and draw it on this page, and then we can all look at it together and ponder what the guy was really trying to do and what he succeeded in doing. And you know, is this why this radio doesn't work? Did he mess something up, or did I mess up? I haven't done anything yet. See, I don't want to mess things up. I want to find out what's going on here before I start fooling with it. I can't add my messes into his messes if that's the case. Coffee time. Well, I just sat down with my coffee cup, picked it up, put it back down, because I realized I think I'm not realizing something here. That, as I said, these lights are in series with these, but these resistors are in series with these. That's really what's going on here. So you can't repurpose these resistors to be the voltage drop element. Or can you? I don't think you can. They have to remain in series with these. Is that kind of what it is anyway? Notice they don't really show anything special about the cord here on this schematic. It just says AC or DC line. That's what this is. This R12. I'll bet you this R12 is the R12. Okay, time for coffee. I feel the urge to rant just a little bit. I didn't watch this video, but I just was drinking my coffee and looking, and there's a video that says 10 million people are going to go off-grid in 2024. I really don't know the details of what they were talking about there. But there's something people are not understanding about this whole thing, about self-generation and getting off the grid. As if getting off the grid is some kind of virtuous thing that we should all be trying to do. But when I started in the power industry, be the late 1970s, I got a job at the power company in Toronto. Not a generating company, just a distribution company. And at that time, it was illegal to generate your own electricity here in Ontario and in many, many jurisdictions. It was illegal. You couldn't do it. You had to get a special license. And of course, nobody in their home would do it. There was no way to do it. There were no solar panels or anything like that, so you really couldn't do it on your own. But industry could. There's nothing stopping industry from building a generator beside their factory and generating their own power. It might be a little bit cheaper for them. It's possible. But it was illegal. Why? And why should it still be illegal, in my view, for people to generate their own electricity? See, there's a hidden cost here coming. Right now, in most locations, everybody's hooked up to the public power source. My house here is powered by a public company. It could be a private company. It doesn't really matter if it's private or public. But the thing is, it's all in on them. They do all the generation, transmission, distribution. All I have to do is offer a panel on the side of my house, and they'll put wires right up to it. And just like the other night, I don't know if I mentioned this, but the power went out here at my house 3 times the other night, which is really bizarre. I've never experienced that. 3 different times. Because of a very heavy wet snowfall that was happening, I think. Anyway, power went out. What did my wife and I do? Well, we just waited for the power to come back on, because we know we're hooked up to the public system, and there's guys who are going to be running around trying to fix it right now. They probably were sitting in their trucks when the power went out. They were probably on duty doing something when the power went out, and they're running out, and they're going to try to fix it and get it all going again. And for all this, I pay a pittance, right? I pay... And my power bill here is about $150 a month. I get all that. I get all that service, all that stuff. But what if half my neighbors got off this public power system, but I didn't? Let's say half the houses in my town got off the public system, the public system would still cost what the public system cost. It'd be a little less energy consumption, but the main cost isn't really the energy consumption. That's water falling through pipes and hot nuclear stuff. It's not that expensive. The problem is operating this gigantic system of wires and transformers and people running around in trucks trying to keep the whole thing going. If half the people aren't buying power from that system, then half the money will disappear. But the system remains. The system is still there. Yeah, maybe less people hooked up to it, so maybe a slightly reduced cost. But on a house-by-house basis, the cost will leap up. And all of a sudden, you won't be able to buy cheap power from the public system anymore. You're going to have to buy the private system, put solar panels on your roof. Well, what's the problem with that? Well, I'll tell you the problem with that. 3 years into your lovely power system, private power system, solar panels, wind, whatever it is you're doing, the power goes out. What do? Are you an electrician? Probably not. Now the power's out. You have your own system. What do? You get on the phone, you start looking for an electrician. Unless maybe you have a contract with some electrical company that is making you pay every month, so they'll come running one time when you need them in an emergency. But if you don't do that, you have to find an electrician. Now, an electrician comes out to your house. What do you think he encounters? It's just like me fixing these radios. No telling what you've done in your house. You got a different set of solar panels with a different kind of control box and some kind of battery hooked up over here the guy's never seen before. And somebody else, who did this to your system? Who did this? Your uncle? Your uncle came over and did that? And now you expect me to turn the power back on with that thing like that? And it took me 2 days to get here, by the way. You've been in the dark for 2 days waiting for me to show up. I'm a harried person because I'm running around from house to house and nothing is standard anymore. And I got a truck. You know how big my truck is? I got a transport truck full of parts now. I have to drag around just in case I show up and you've got one of those kinds of panels that, for crying out loud, that needs a doohickey jigger. I got 5 doohickey jiggers in my truck and I haven't sold one in the last 6 months. The whole business is going down. By the way, you're paying through the nose for this. I'm out here in the middle of the night trying to turn your power on. You got a stupid system here. Your uncle did something to it. I don't even know what he did to it. And you're begging me to turn the power on. I can't turn it on until I inspect this whole thing and get it certified again. Because your insurance company is watching what's going on here. Like, am I crazy? Am I not telling a story that's true? This is where everybody would be going. You know what we should do? Plug our stuff in the wall. Thank God there's a public common system and support it. And forget this nonsense about local generation. Look at how excited I am. Holy smokes. Well, I did work in the power industry in a distribution company. So, stupid. This is stupid. Now, solar panels, if you're in a remote location, absolutely. Get the wind going, get the solar panels, buy the batteries, buy a gas generator for crying out loud. Because getting power off the public system in a remote location is either way too expensive or just isn't even there. We have communities here in Ontario that are very, very remote. Fly in, no roads, that kind of stuff. So, okay, they got to develop their own power thing. And maybe a house-by-house system makes sense in a case like that. I don't know. But here in the urban area where there's a high density of houses, it makes no sense to try to make every house supply its own electricity. So the hysteria is going on out there. I mean, I love the idea, but the bigger picture, it is a thumbs down, big time. Big time. Or people are going to put in these private systems and they're going to want to maintain a connection to the public system just in case the power goes out in their own private system so they can flip onto the public system. You know what that's going to cost? That's going to cost a fortune. Yeah. So shame on all of us. Nobody's talking about this. Public companies don't talk much. They don't have budgets to come out on TV and tell you stuff and whatnot. So all these engineers, I am sure of it, engineers all through the system are pointing this out and saying that this is crazy. We can't let this happen. Because ultimately the whole system will end up being incredibly expensive. Combination system. What a disaster. Okay, that's the end of the rant. I'm over with the rant. I apologize for it, but You know, I do have a YouTube channel here, and once in a while I think I have something to say. So unfortunately, and as I've mentioned before, my mouth remains connected to my brain. I can't seem to interrupt that, so away it goes. Well, I'm going to have to stop for a bit, calm myself down in front of another YouTube video, and then I'll come in here and actually do something. Yeah, do something. Well, I've noticed something that's important to recognize, so I'm going to show it to you with a close-up camera in a moment. The last radio I did was another 5-tube radio, and it had what I would call a warm chassis, where the chassis is connected to the radio guts by only one, okay, maybe two things, by one thing, a capacitor. There's a capacitor that runs between the chassis and some point in the circuitry, a special point, and that's it. That's the only connection. Then there's other radios where there's a direct connection right from the power line right to the chassis. Those radios are dangerous. Those radios are hot chassis radios. What makes them dangerous is not realizing what's going on. And a unpolarized plug. This is a polarized plug. And hopefully this has been done the right way, which we are going to examine right now because I need to know this. Now, while I'm working on projects in my shop, on my bench, I'm plugging them into this thing here. And this guy is hooked up to an isolation transformer. Not only that, but there's another one behind it for no good reason. What I was doing here, I'll show you, is I was tracing out the circuit pictorially as best I can. To me, that's the first step. You make a picture of what you see on paper. That's difficult enough in itself. That's 3D. This is 2D. That's challenging. This is the on-off switch, and this would be the control that you'd be turning. Turn the radio on and off. This is the switch. And if you can see, there's a wire that comes straight from one of the prongs on the power into the switch, and then if you close the switch, it's connected right to the chassis. I'm going to show you that with this camera. And this is definitely something that, you want to know about this early on. So that's why I'm showing it to you. As soon as I've noticed this, because I really hadn't looked for it before. So here's the volume control. Okay, and on the back is the switch. You can actually see the switch is a separate piece mounted on the back of the volume control. There's the switch contacts. One of them, this one here, is connected to, can you see it? That's an actual piece of power wire right there coming from the plug, straight to here. Look at the other side. Now, close the switch, you hook up to that wire, and look, it's soldered right to the chassis. Now, if you have an unpolarized plug, you got a 50-50 chance that when you turn this radio on, the chassis comes alive at 120 volts. The whole thing is there, ready to kill you, really. This is not current restricted in any way. You could light a light bulb off it. Very dangerous. Not to be fooling around with these radios. Now, often the controls will be recessed. They're not recessed in this radio. So this is an early radio before these issues became something that engineers began to take care of. So you certainly, if you pull the knobs off this radio, these are sticking right out. There's a good chance these are grounded to the chassis. They may not be, but there's a good chance. So grabbing this, you're grabbing the chassis, you're taking your life in your hands with this radio. Unless you're well aware of what you're doing. You're well aware of the circumstances. As we keep going here, I've got I want to show you a couple other things. So here on this piece of paper, I have sketched out this diagram. And this is the resistor, which is supposed to be paralleling the light bulbs above. And so you can see off of this and off of this are two yellow wires, and they're disappearing through a hole. They're heading up to the light bulbs up here. So the light bulbs appear to still be connected to this. And then we have an incoming power coming in, connecting to the rectifier 2 pin. This is one of the heater pins. These two darker pins are the heater pins on this tube. So power coming in, starting on this tube. And then I got this diode connected. And the diode comes over here, which has something to do with the lights. but there's resistors up above. What is going on here? A possibility is somebody did this, they didn't realize something, and they put these resistors in for some reason thinking they were missing, when in fact it's this thing here, which is this thing. Maybe I'm going to be blurry. Where there it is. That thing right there. You can see the diode. You can see it's going down to a terminal that has a power wire on it. You can see the brown power wire running there. It's got another wire on it, not a bunch. It's got a red wire on it. And look at the terminal of the tube above. This terminal here. This one. Why is it bent like that? I don't think there's any particular reason for it. It looks like a red wire connected to it. And we go back to the resistor. Where are you? There's a red wire on the third terminal. You can just see it there. On the third terminal of the resistor. And it shoots over to a terminal on the tube. And that's this red wire here, coming from that terminal going to this. You know what? This is the other heater terminal. I got no clue. I still don't understand what's going on here. And I have to turn this pictorial thing into a more schematic diagram before I start to understand what the story is. And often when I start investigating stuff like this, the story looks extremely complicated at the start. Spaghetti jungle or something like that. When you're all done, you look at it and go, well, this is just normal. that could be where this is going. Okay, I'm going to continue sketching away here and trying to figure out what's happening. Oh, I didn't quite finish the hot chassis situation here. Yeah, so the other radio I would call a warm chassis, because there's a capacitor and actually a resistor too, kind of in between the chassis and the radio circuit. Now this one, there's nothing. It's hooked up direct. So I'm going to put one of these on the chassis and the other one. So there. So we see the grounded one, the wide prong one, which is the grounded side, earth side, let me put it that way. The voltage of the earth is running the same as the voltage of this side of the power system. So if you stand on the earth and you touch this, you can't get a shock because everything's at the same voltage. This side is the earth side. Much better. Thank you, Britain, for that. Now the other side is just wide open. Oh, that's the wrong switch. Yeah, the switch is on. Let's turn it off. Okay, apply your muscles. Maybe that's all the way up. Yeah. don't muscle it too much. Come back here. Now what's happened? Okay, actually good. Be just a little more certain here the way I'm doing this. Okay, appears to be nothing at all. With the switch open, no connection between the prongs and the chassis. Say, Jim, why are you checking it so carefully? Because it's more than once in my life I found out that what I thought was true isn't true. That's happened more than once. Nothing happening there at all. Okay, so this has been done in such a way that the let's try it again here. What I'm gonna do this. So I'm gonna touch the grounded prong and touch the. So you see it going to 0, eh? I think he's done this the wrong way, because I'm on the switch now and I'm on the grounded prong. The grounded prong is going to the switch. Nothing. Coming back the other way, though, you can see something. Coming back the other way means I'm actually running electricity through the radio circuit in some weird way, and it's coming all the way back to the switch. through the radio. That's why this hot chassis thing is such a problem, because you might think you've solved it by doing something, and you turn the radio off, and whatever you did, that's what's going to happen. Okay, you did it wrong. It's inconsequential while I have it plugged into here, but if I plug this, let's prove this. Okay, let's prove this. If I turn this on, can I turn this on? Is everything okay here? Okay, I'm going to turn it on. This will tie together those two posts and make this chassis connect to here. Maybe that's done right. Okay, we're going to try it out. It's switched on. I'm plugging it into a regular outlet here. So this is danger gem. Okay, I'm going to put the power on. This will make the radio come on. So we're looking for AC voltage, not resistance anymore. And I'm going to need to, I want to ground one of these because I'm interested in what any voltage relative to the earth. So I'm going to connect this to a earthed wire. Yeah, as I've said many times, the term ground is thrown around so much in North America that it doesn't mean much. Or it means different things to different people, which is really bad. Really bad. So I like to say earth. Okay, so we're ready. 600 volts AC. Checking the chassis. Both on and off. Okay, I'm applying power now. We don't have to let the radio warm up. Nothing there. And the radio is warming up. I'm going to cut the power. I really don't want to operate the radio very much. I'm going to turn it off. Demonstrating tremendous muscle power. The radio's now off. I'm going to plug it back in. Where'd it go? Where'd the plug go? It is plugged in. I'm going to turn the power back on. Okay, the radio should be operating again. No, I've turned it off. Now what do we get? This is the hot chassis problem. So, could you light a light bulb from this? That's an interesting question. I think the answer is probably no. But let's give it a try. Can you light a light bulb off that? If you can light a light bulb, then it's deadly shock hazard. Is this going to be long enough to do this? No. You need another longer clip lead here. Here's a good one. Here's a good one. Okay, so I'm going to plug this into a ground terminal that I have right over here. Okay, so this is grounded. And I'm going to attempt to light this light bulb off this chassis. That's a kill you dead. Kill you dead. I don't like it. So what I'm trying to demonstrate is with this hot chassis connection thing, you can't escape the hot chassis. You can make it hot when it's on, or you can make it hot when it's off. But you cannot escape it. That's my opinion. So don't, anytime you see one of these guys with a wire going straight from the power cord straight to the chassis, all your warning lights should be going like crazy. Especially if you're working in a shop without an isolation transformer. Now, I have a couple here, but I used to work in my old shop not with an isolation transformer. And what I did in that case was I had what I called my hot chassis light. It was just a Christmas light bulb, a regular incandescent Christmas light bulb. Soldered a couple wires to it. One wire connected to earth, to ground, to the third prong, if you like, on the power system, and the other wire connected to the chassis of the project I'm working on. And if at any time while I was working the chassis went live, the light came on. And that kept me relatively safe. So, dangerous guy. Don't fool with the chassis. Now look at the situation here. This is a classic. How do you get electrocuted by one of these radios? Look at, yeah, first of all, you have a ratty old antenna wire. Here's a ratty old antenna wire. It's ratty because it's been unwound and wound and unwound and wound. It's been stretched out and dragged and everything. And all that working has ruined the insulation. You have bare copper here. Bare copper. Now normally there'll be a capacitor in here to protect the person holding the antenna while they walk in their backyard with bare feet, because they're really stupid, holding onto this wire that's going to a radio they've left plugged in the wall. I mean, these people are really stupid. But that might be okay, because with the capacitor and everything being new and normal, fine. But what if it's not new and normal, and in fact the insulation has come off? Like right here, see, the insulation has come off. Now this radio has a rubber grommet here, so there won't be a short. But in a lot of radios, there'd be nothing. There'd be nothing but steel. This was short. Now the antenna touches the chassis, along with ruining the operation of the radio. Now this wire is hot. You go in your backyard, check the antenna. Oh, it fell down. You grab the antenna, and next thing you know, ambulance attendants are taking care of you. So danger, danger, danger on these kinds of radios. I don't know if I can stress it enough. There's just like a certain age range of radio. This is from the late 1930s, where this kind of situation exists. So your experience with one 5-tube radio could be quite different from another 5-tube radio because of the way they've handled this situation. In this radio, it's not handled at all. This is really kind of surprising to me, unless, you know, on the back it had some no user serviceable parts inside, refer servicing to a qualified person, something like that. Maybe that's your only warning. I don't know. Boy, I am really speeching, but this is a really good opportunity to show the situation here. I'm afraid to even touch it. And personally, I'm pretty good at making sure I'm not grounded when I'm doing this work, even though this is plugged into an isolation transformer. I'm standing on a rubber back mat. I have rubber soled. That's my shoe. Rubber soled shoes. Can you read that? Manitoba. Yeah. And so I'm pretty good at keeping my one hand out of trouble when I'm using the other one. I put it behind my back, stick it in your pocket, all those kinds of rules. I try to do them. Okay. Still haven't got a clue what I should do, if anything. I still don't know why that diode's in there. I don't know what it's doing. I'm spending way too much time talking and not enough time doing stuff. Oh, I drink some more coffee and relax. Does that go together? Okay, so I hesitated on R12. Is R12 actually the resistive power cord? And the answer is yes, it is. Here we can see R12, 145 ohm, 15 watt resistor wire in line cord. 145 ohms, 15 watts. That's a lot, 15 watts. To dissipate that off a resistor is challenging. If this were being dissipated off the resistor, the wire wound resistor, off of this thing, 80 ohm tap wire wound resistor, it doesn't actually give the wattage of this resistor here. Huh, am I not seeing it? That's interesting. Don't know what the wattage of this is, but it would probably be 5 to 10 watts, able to dissipate 10 watts, not 15. That's why they put this in this was a good idea from one point of view. They're putting this resistor in the line cord. The heat is dissipated over a long area and outside of the radio, not inside the radio. So that's the advantage. So you're going to move this 15 watts inside the radio, like maybe put a 15 watt, 150 ohm resistor inside the radio. You're going to have a heater in there. This is really a problem. My guess is it wasn't really recognized. The guy who did it may not. I mean, it had been done long enough ago that he couldn't access this kind of information that I have in front of me now. Didn't realize the cord. I think this is quite common. Didn't realize the cord had a resistor in it, or was a resistor, and stuck a new cord on, and the radio's just happily running along with extra voltage. What I can do in my shop is I can just keep the voltage turned down just in case while I continue working on the radio, as if this resistor exists down here. This is really it's really an annoyance. So looking again at the schematic, so I see a wire leaving from this point and heading up to the lights. I see another wire leaving from, I don't know if it's this point or this point. Well, one side has the power cord and the other side does not. So one side's seeing the power cord and the other side of this resistor is seeing this. So it'll be tied straight to here. That's exactly what's done. Assuming this is pin number 1. I think this is pin 1. So this resistor appears to be still doing exactly what it was doing. That raises a question, what are these other resistors that were installed up here doing? The assumption then is the cord resistor has been forgotten about and the radio's running with too much voltage. How does a diode fit into this? The diode, I got the diagram right in my hand. The diode is connected from what would be here. The diode is connected here to the power cord. So it's from here. Of course, so this resistor doesn't exist. It's connected from here to itself. Wait a minute. What? It's connected from here to here. There's no what? Okay, I got to do more work because I don't know what's going on. More coffee. Okay, let's take a look at what I think I figured out here and see if I've got it right. So you're looking at the tube base for the rectifier tube, and I'm looking for my pointing stick here. Here we go. So it's hard to see the actual hard for me to do this too. So this is the diode right here. It's hard to see, it's a little out of focus. One connection is up here, this way out of focus connection here. This is one end of the diode. The other end of the diode is going down to this terminal. On that terminal is the power wire. You can see it just below my pointer. And this red wire. The red wire disappears from view, but what it does is it just connects to another tube terminal right over here at a site. So we look on the schematic, which we will in a minute. You'll see the two plates and the two cathodes in this double tube have been tied together. So this is one plate, and of course they put the other plate way on the other side of the tube to make these connections distant from each other because of the voltages involved. But in this operation there is no voltage because in this particular radio they've just shorted them together. They turn this double tube into just a single tube, kind of. So we see that the capacitor is connected, the diode is connected right to one of these with the power cord on it. Oh, okay, I'm getting quiet here again. So up here, this connection, these wires, this connection here I'm pointing at is actually on that resistor. So they've connected, or somebody's connected this diode from this resistor terminal down to the plate of the rectifier tube. To the plate of the rectifier tube from here. So let's look at that on my my diagram here. Switch cameras. I find this stuff very confusing. When somebody's done something to a radio like this, I have a heck of a time sorting it out and feeling sure of what I'm sorting out. So I don't even have the diodes drawn in here anymore. I had it here, I had it here. So one leg of the diode is tying to a terminal that has the power cord coming to it. So here's the power cord, and it comes along, it ties, the power cord ties to the plates. The plate is pin 2 and pin something else, pin 5, I don't know, pin 2 anyway, and you can see a connection of the diode to pin 2 of this tube. So the diode is connecting here. There's no question. One side of it. The other side is connecting. Where? Where is it connecting? I think it's connecting here. Because it's the other side of this fixed resistor here. And so what is this thing doing? So he's connected it to the heater string. I think it was a failed attempt to bypass this tube, to put a diode across the tube. And what he's done is he's hooked the diode from the supply side to the supply side. He never got it to the other side. So I don't know what is going on. We're going to turn on this radio. We're going to look for B plus in here and see if there's any B plus being developed, because the radio doesn't work. It's possible it's just got no B plus going through the tubes. No positive voltage on the plates of the tubes. The tubes can't operate. They will not operate. So let's do that next. We'll turn it on and just look for voltage here. And that would be the same as looking for voltage on this capacitor. So what I'm going to do, assuming the guy did his work right, and I really think he probably did. And I think all that's happening here is I'm just discovering what he did. I'm not discovering what he did wrong. And the reason the radio is not working has nothing to do with what the guy did. Something else has happened. So we're going to want to hook this meter up onto the positive terminal of this capacitor. Yeah, capacitor. It has to be this terminal here. It has to be here. Okay, we're going to hook up the negative to the other terminal as soon as I find it here. So we're just going to read the voltage right across the filter capacitors. Capacitors. And see what we get. So we're going to read positive voltage somewhere around 100, 110, something like that. That's what we should expect. Okay, are we all set? Everything's set? Just clear my bench up a little bit here before I turn the thing on. I try to make a habit of doing a little straightening up just before I turn stuff on. And that keeps a little bit of cleanup activity going here and keeps my bench from becoming a heaping pile of stuff. And then when something goes wrong, you can have a heaping pile of stuff on your bench and something goes wrong. Oh, jeepers, what a bright light I'm using here. You may be paralyzed because there's too much stuff to look at on your bench. Where's that thing? Where's that tool? Where's that switch? I don't want that to happen. Don't expect any panics here. Let's just make sure this antenna wire is kind of out of the way. Okay, I'm going to plug it in. So, put a polarized plug on. Now it's safe? No. Never safe. Solidly attached chassis, never safe. Argue in the comments if you wish. Okay, we're ready. Here we go. Dim bulbs in. Radio's turned off. Radio's turned off. Yeah, radio was turned off. Well, we're not going to get anywhere there. Here we go. Try again. A diode rectifier placed in the right place would have generated B plus by now. Vacuum tube takes time for the heater to heat up before it can generate the high voltage. I wouldn't call any of that high voltage. Am I doing something wrong here? No, I don't think so. Here we go. Now we're getting somewhere. So that's a vacuum tube rectifier warming up, enabling the high voltage. Look at it go. That's pretty good. Well, we don't need to continue this test. My guess is that diode is doing absolutely nothing, and I can cut it out and it'll have no effect on this radio. That's the impression I got now. Is it true? Hey, okay, I could pull the rectifier tube out, but you know what? I mean, that would cut all the tubes off. That would cut everything off because the heaters are in series. So I was thinking I'll pull the tube out and see if it still generates high voltage. In case the guys in case I'm wrong and the diode's in the right place and somehow it's just doing the same thing as the tube, and you could do away with the tube, except the radio wouldn't operate. I don't know. I must go and consult the coffee grounds in the bottom of my coffee cup, like reading tea leaves. I had a neighbor who was a professional tea leaf reader. Really. Madame Helena. Yeah. Okay, well, I'm going to cut one leg of that guy in case it turns out it's needed. Follow my own safety rules here. Okay, we're going in. This is probably the easiest place to reconnect it here. I need to. Okay, it's cut and it's free. So that diode. Are we ready for another try? Now, how will I actually know that this didn't? What kind of things could happen here? I just don't think anything's going to happen. But one is these lights could do something funny. Why has he put this here? We need to make this measurement. I think I want to leave it like this. I only have one light in. I only have one light in. If I only have one light in, boo, I don't know what to think. I'm going to put the other light back in. Because it may, would they design this so if one light burns out, the other guy gets cooked up right away too? I don't think they would make it that way. Maybe that's what these resistors are. Scare myself. Think I'm getting a shock when I'm not. Come on, you were hard coming out. Ooh. Oh my gosh, I'm going to ruin this light here. If I haven't ruined it already. See? Should have left well enough alone, Jim. What happened here? Come on. I've crushed this light. Oh. Now the base is loose from the glass bulb. Ay, 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 ay. Has he ruined it? Hey, we're going downhill here. Still good, but if I twist this glass anymore, why won't this go in? Well, this is just a standard light, a standard socket. Because I mean, the soldering down here, he's sometimes when you push these in, the little plunger comes out the back. Because there's a spring. There's a spring. The plunger comes out the back. Did that make sense? I don't know if I... Come on. The plunger doesn't come out the back. You can't sink the... yeah, you can see the little plunger part coming out. It looks like it's getting interfered with right here. Let me just pull that up. Go like that. Fixed. There we go. That's all it was. Blocked plunger. Switch is off. Diode's out, but it's hanging in there, but it was hanging safe. Hopefully it's stiff enough it hasn't wandered around. Made some other contact. I'm sure that hasn't happened. Ooh, 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 ooh. We're set on resistance here. That wasn't going to go well. Okay, we are ready once again. Fire this guy up, see the B plus develop, and then conclude the diode was a mistake from somebody who didn't comprehend the unusual arrangement. See, if you know, there's a lot of paradigm thinking that goes on, right? When you look at something like this, You look at it and your analysis is done on not what you're seeing but what's in your head about what you've seen before. So if there's something here you've never seen before, it's going to be hard for you to realize that's even happened. Yeah. Something we've never seen before. Well, okay, I think I'm ready. I can't delay any longer. Dim bulb's coming in. Switching it on. I gotta hold on to this to do it. Okay, first of all. Well, how do you like that? Okay, tubes are not lighting. Tubes are not lighting. Did I just do something wrong? Then 115 volts. And when I turn this on, watch this meter over here. It didn't drop at all. By taking out that diode, I have disconnected the power from the rest of the radio. See, I think somebody clever has done this. And I'm thinking what they've done. Let's go back to the instant on television. So when I was a kid, I had a black and white TV in my bedroom that a neighbor had given me, and that was my cool TV I had. It was a smaller black and white TV. The picture was very dull on it. I acquired a rejuvenator. Well, not a rejuvenator. I guess it's called a rejuvenator. I've got one here somewhere. Is it hanging right around here? It was hanging right around here. Would you believe it? I got a picture tube rejuvenator, but I can't get my hands on it right now. So I plugged in this rejuvenator. It boosts the heater voltage on the picture tube heater. I think that's all it does. And the result is, hey, you get a little more life out of your television. So that was my black and white TV, but it wasn't instant on. You had to turn on and wait for things to warm up. So I wanted to make it instant on, and I learned how that's done. You just take a diode and put the diode right across the switch, the power switch. So when you turn it off, it's not really off. A half wave is allowed, half wave of the power system is allowed in to the TV set. This is enough to keep the heaters a little bit warm and keep the picture tube heater a little bit warm. And when you turn the TV on and give it the full voltage, because now you're shorting out the diode, which is giving you half current, half current, I guess. Then the TV comes on really quick. Within a few seconds, you got the TV on. Instant on. That's what it was. So thinking about that now, using a diode to supply half as much power to the thing. Is that what he did here? The line cord went away. He replaced the line cord with a diode. And the idea, the diode is now only allowing a half wave to reach the rectifier. You know, this is a dumb idea because the rectifier itself is a half wave rectifier. If you allow the wrong half wave to come through, then the real rectifier won't do anything. If you allow the correct wave to come through, then the rectifier is going to do what it always did anyway. How does a diode help in that situation? Well, it did something because the radio stopped working. So okay, so that's it for today. So I took a dead radio and killed it thoroughly today. Tomorrow I'll try to bring it back to life. I'm really quite confused on what is going on here. Thanks a lot for watching. This is what fun looks like when you're working on these things. See ya.